There we go. Now you can kind of read it. Related rates. Okay, so I'm going to go through the lecture we had the other day on related rates for those of you who had class. Otherwise, it might just be a nice review. A related rate is when you are given the rate of one thing or several things, and you want to find the rate for something else. The key is to find an equation that, oddly enough, relates the two things. So, first example. I didn't write down the words for the example because I was lazy. These are going through the examples on the slide, and this is, I don't know if you can read that. You've got good eyes, you probably can. The first problem I'm doing is air is being pumped into a spherical balloon so that its volume is increasing at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the radius is 50 centimeters? So, what you want to do is, I don't really need to draw a picture, but it's fun to draw a picture of a circle. There you go, circle. What I'm given, here, let's just draw the problem. What I'm given is that the change in volume with respect to time is 100 cubic centimeters per second. I'm looking for the change of the radius with respect to time when the radius is 50 centimeters. Now, so I need an equation that relates the volume with the radius, which is just the volume equation. So I have volume equals 4/3 pi r cubed. If you didn't remember that or didn't know that, don't worry, I'll give it to you on a test. So I will take the derivative of this with respect to time. So just like we treated the y's when we took the derivatives when the y's and x's were all mixed up, now any variable has to be treated like we treated the y. So I have dv dt is, okay, so this is a constant. I need to deal with the r, bring the 3 down in front. So 4/3 becomes 4 pi r squared times dr dt. Fill in what I know, solve for what I'm looking for. So I know that dv dt was 100. I was told the radius is 50. I'm solving for dr dt. So dr dt is 100 over 4 times pi times 50 squared. And I never put that in a calculator, but I'm assuming you can handle that. So, next question. We have a ladder that's 10 feet long. It's resting against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down when the bottom of the ladder is 6 feet from the wall? So, I have my picture here there's my ladder. This distance from the bottom of the ladder to the wall is changing. So if it's changing, I'm going to give it a variable name. The distance from the top of the ladder to the ground is changing, so I'm giving it a variable name. The ladder doesn't change size. It's always 10 feet, so that's what I stick in there. I'm told that the ladder is going away from the wall at 1 foot per second. Since it's getting bigger, it's a positive 1 foot per second. I'm looking for dy dt when x is equal to 6. Okay, so let's look at what we have. The equation that relates x and y is, of course, using the Pythagorean theorem. Oh, I can't cover this. I'm trying to be sneaky. Okay. I know that x squared plus y squared is equal to 10 squared. So I'm going to take the derivative of that with respect to time. So 2x becomes 2x dx dt. 2y becomes 2y dy dt. 10 is a constant. That's 0. Don't take the derivative of that. People do that. They put the 2 down there and they do weird shit. Don't do that. Okay, so I have this. Too many 2's. I don't care about them, so I'm going to divide through. Now, fill in what I know. I know that x is 6 at the time I care about. Dx dt is 1. Y, I have no clue. So I have to go back to the original equation. X squared plus y squared equals 10 squared. Fill in my 6. Use this equation to figure out what the y is, and so y is equal to 8. So then I can plug that back in here. So now I can say 6 plus 8 times dy dt is equal to 0. Solving for dy dt, I get negative 3/4 foot per second. I'm not sure where all my little pieces of paper went to. Here we go. So, next related rate. A water tank that's in the shape of an inverted circular cone with a base radius of 2 meters and a height of 4 meters. If water is being pumped into the tank at a rate of 2 meters cubed per minute, how fast is the water level rising when the water is 3 meters deep? So what I know is, there's my little picture. I went ahead and wrote it as a triangle so I don't have to think about this in 3D. The volume is dV dt is 2 meters cubed per minute. That's how much it's being pumped in. It keeps going out of focus. Sorry about that. I'm looking for dH dt when h is equal to 3. So I know the volume of a cone is 1/3 pi r squared h, but I only want one variable. I don't want these two. So I know that I can look at these similar triangles here, and I can see that 2 is to 4 as r is to h, because they're similar triangles. So r over h is 1/2, so r is equal to 1/2 h. So I'm going to use that and plug it in for r. So cleaning it up algebraically, I get volume is equal to 1/12 pi h cubed. Now I can take the derivative with respect to time. dV dt is 1/4 pi h squared dH dt. Fill in all the crap I know. 2, 1/4 pi 3 squared dH dt. I can solve dH dt. I get 8 over 9 pi, which is approximately equal to 2829 meters per minute. I can read. The next question. Fred's car is moving west at 50 miles an hour, and Ethel's car is traveling north at 60 miles an hour. Both are headed for an intersection of two roads. At what rate are the cars approaching each other when Fred's car is 0.3 miles from the intersection and Ethel's car is 0.4 miles from the intersection? Okay, so let's draw a picture. All I really care, did I draw it right? It still doesn't look right. Oh, because I didn't fix it on that one. Okay, sorry. So Fred's car is, I switched the rectangle. So here I've got Fred's car is going this way, which is east instead of west. I don't know what the heck I'm doing. And that's Ethel's car. And there's the distance between them. The dF dt, he's going 50 miles an hour. dE dt, she's going 60 miles per hour. I care about when Fred is 0.3 miles and Ethel is 0.4 miles from the intersection. Now officially these should actually be negative since they're going to the intersection, and so F and E are getting smaller, but I think since we're squaring them and it's all going to work, it'll all work out in the end if I did it the other way. Okay, I'm looking for dx dt. So I know that f squared plus e squared equals x squared. I take the derivative, I get 2f df dt, 2e de dt, 2x dx dt. Again, everybody's got a 2. Let's just get rid of it, divide everything through by t. Now I'm going to fill in what I know, and again, I'm missing one piece of information. I don't know what that x is, but I know that at the time I care about, Fred is 0.3, Ethel is 0.4, and that's a nice pretty Pythagorean triple. I get that x is 0.5. So here I can plug in what I know. I'm looking for dx dt, so I add these two, well, multiply and add these together, and then divide by 0.5, and I get 78 miles per hour. Last problem. A man walks across the stage at a speed of 4 feet per second. A spotlight is located 20 feet above and is kept focused on the man. At what rate is the spotlight rotating when the man is 15 feet from the spot directly below the spotlight? Okay, so we're rotation, so we're actually going to deal with angles on this one. So, draw a picture. I have the man's here. He looks kind of creepy in the picture. I know that the light is fixed at 20 feet above. This is the distance the man is from the bottom where the spotlight is shining straight down. I'm going to need y in a minute, so I went ahead and wrote that out. Okay, so I'm given that dx dt is negative 4 feet because he's walking this way. And d theta is what I'm looking for, and x is 15. So something that involves the theta and the x is tan. So tan of theta is x over 20. I take the derivative. I get secant squared of theta, d theta dt, and the derivative of 1/20th x is 1/20th dx dt. To fill in what I know, I need the secant of theta, which means I need what y is. So when x equals 15, y equals 25, you can solve for that. So secant of theta is 5/3. So plugging into my equation, I get 5/3 squared times d theta dt equals 1/20 times -4. So d theta dt, when you solve, is -9 over 125 radians per second. So that's how fast it's rotating. And so those are several related rate problems, and I hope that'll help you if you can slow them down and look at them. I'm going to have to get the mouse to shut this off.